SAFE Software is pleased to present the 2009 FME International User Conference. This session is presented by François Valois, the Product Line Manager for Geospatial Server Products with Bentley Systems. François is also responsible for Bentley Geospatial Desktop products, including Bentley Map and Bentley Descartes, to name a few. François also has prior experience, having worked at ESRI as a product engineer responsible for designing, testing, and documenting functionality related to the geometry and topology subsystems.
Merci. Donc, la présentation va être en français. No problem. No, I'm just joking.
I was going to say, I can hang around for that.
Okay, so my name is François. I'm a product line manager for Bentley System Geospatial Division. And working on the geospatial desktop products, actually. So today we're going to talk about an introduction. What are the different components building up the 3D GIS? We're going to talk about BentleyMap, the benefits of Bentley FME Integration, how we actually leverage BentleyMap, FME inside BentleyMap, and we're going to show a CTGML example, or urban planning kind of example, demo going on inside BentleyMap using FME. So BentleyMap is basically a product built on top of MicroStation, which you probably know better than the actual BentleyMap name, which is our flagship product. So our mission at Bentley is to sustain infrastructure. So basically the infrastructures provide the interface between the people and the planet. This is what makes our life easy. It's the water, it's the buildings, it's everything that makes our life simple. So there's a lot of urbanization, and it's accelerating a lot. So the battleground really for sustaining infrastructure in the world is located at the local government more and more. And 3D is required in all of that work. All of it requires 3D, pretty much. So CTGML is a new OGC standard. There was a presentation earlier. I don't know if you've seen that. But it's really a 3D data exchange format, XML-based. And BentleyMap and FME Integration allows you to take full advantage of CTGML or any of the other formats, by the way. But this one I wanted to just stress because that's an important one. There's really three building blocks for the 3D City GIS. There's the 3D modeling and quality control. There's the persistency management and serving of the data, and the exploration, analyzing, and designing in 3D, basically. So we're going to explore each box. In the 3D modeling and quality control, a lot of the aerial survey platform are built on top of MicroStation already and other products. A lot of surveys are done on the field, and also a lot of data already exists. So we want to transform it and load it into other systems, and that's where FME comes into play. So it allows to quickly create accurate data, performing quality control check on the data itself, allows managing feature object as well. And that's one of the BentleyMap best benefit, is that it brings the CAD to a next level. It makes real feature out of the data rather than just CAD things. So there was that whole thing about how to bridge CAD and GIS. Well, you don't need to do that anymore. So that's an example of what you could do inside MicroStation and BentleyMap. That's actually City of Quebec, which have provided us their city model, which was all done inside MicroStation with photogrammetric tools on top. And so that's the Château Frontenac. That's my hometown, basically. If you've never visited that, go for it. It's a nice town. It's one of the only historical towns in North America, in fact. Then the other part is exploring the data, visualizing, navigating, query the data, more for analyzing it, spatially, non-spatially, and then design it, building road utilities, which are, high-end engineering like with building information model, roads, with all products provided by Bentley and AutoCAD, for example, which will allow you to design that data. And the analysis, for example, support the decision process. It involves geometric and semantics exchange, structured data and unstructured data. So there is well-structured database kind of things, or DGN with attributes with a feature model. But there's also a lot of CAD data out there that you need to deal with. And so in urban planning, you got cellular studies, noise propagation that was mentioned earlier today, line of zone of sight, landslide analysis, energy simulation, and so on. And there's a lot of applications and more coming up in this area. That's an example of a solar study in Toronto, which Toronto has a city model of the entire city, and they use a lot of the Bentley technology to analyze it and do solar studies whenever they build a new building to make sure they don't cause any problems. Then the middle piece is actually persisting the data in spatial database, such as Oracle or SQL Server. Design, as design files, so DGN files or AutoCAD files, BIM, so business building information model, that is like the equivalent of GIS for building, and actually standard document, serving this data through a service-oriented architecture, through standards, like CTGML, net services, and so on. You also need to manage information, user, projects, workflow, and all of this to have an integrated system working together. So BentleyMap is a conventional GIS system, except that it's pretty strong in 3D because it has its root coming from MicroStation, which is probably the best 3D platform in the world. And basically it allows you to control with a user interface you can use to with a map manager kind of interface where you can take actions, do buffer overlays, and so on top of it. It has a feature engine embedded in it. That's what we call XML feature modeling. So it basically has an XFM schema, which is an XML-based schema, which drives what you could do inside the BentleyMap application. So it's an open, also XML format. It allows you Oracle spatial editing directly, spatial analysis and presentation, search, browse, and so on. And it's also a GIS development platform. So that is BentleyMap there's an animation on that, which basically allows you to view, edit your data, assemble and integrate, create map reports, feature. It has the feature modeling engine, create custom application, analyze and make decision on all your geospatial information, and in particular the 3D one, which is of interest here. So this is our architecture in Bentley Geospatial. We get several products that range from the desktop to the servers to publishing, which allows you to deal with a whole slew of data. And FME is bringing even more format to us that we don't want to have to deal with. It's just too much work. So benefit of Bentley and FME integration, it brings the power of the industry standard geospatial ETL. There's pretty much no one else in the market that is that advanced. Gives Bentley user access to all of these formats, ensure excellent interoperability between Bentley GIS and other GIS, allow early adoption also of 3D GIS formats such as CityGML, which is not obviously used in very, very commonly, not as common as other formats. It also allows us to give fast access to new formats. Safe Software just does that all the time. Very fast access and adoption to new format. It solves the CAD and GIS interoperability, but at the same time gives smart object to the CAD users. Not only just CAD with no attributes. You can have attributes. You can also have semantic representation inside the Bentley platform. It allows producing data using the right tools and share it with other users. You might want to use Esri to do analysis, but you want to capture your data in something that goes quickly. And you could use the BentleyMap platform to do that, export to something else, and deal with the data much better. So there's really two ways you can integrate with FME. There might be other ways, which I don't know, but you could write an FME plugin and so on. What we chose to do is use FME Objects directly. So instead of supporting 220 formats, we actually support one. It's FME Object, and we deal with that. And so allows us a simple transformation, coordinate system, and so on, and will allow us to leverage more and more format as time goes. So we have written our implementation as FME Object.NET APIs. I don't know if many other vendors do that, but we've jumped on the opportunity to use the .NET API. We have two types of support. We have the standard strategy, which applies to pretty much all formats, or formats that we haven't tackled yet. And we also have format-specific strategies, which take advantage of all of the of the threat, I guess, special things, special attributes. So that's a case, for example, for CTGML and other format, which just don't fit in the typical FME object. So they have defined, FME has defined some threat object or attributes that we can leverage to make sense of the data. For example, in CityGML reader writer, we used to encode things like the level of details, geometry names, and so on. So we're also making use of the feature model, using many different kinds of property types. Array and structure, parent-child relationship are modeled in CTGML and then brought up inside the BentleyMap platform, so you know what things are related to what, and you can also have custom behavior on it. We're using the geometry model, of course. Pretty much all geometry types, box, solid, and so on. That is in the CTGML case, for example. The only one we don't support is CSG solid, which we use FME dialogues as well, and some you're going to recognize in the demonstration later on that you'll see something that you're used to if you're an FME user, this file format browsers and kind of things like that. We make heavy use of caching, support FME caches, allow reading the format in memory first, then to do any subsequent scanning from memory faster for faster result. We use the reader writer. We're not leveraging coordinate system. However, we have the same open source library underneath that FME, so there's no problem there. The business model is that we require an FME desktop license so that, to run the translator on the desktop itself. So we don't try to resell FME, we just get, pretty much everybody's got FME somewhere in their organization, so we figured that it wasn't a big deal. If you're not familiar with the CTGML, well, there was a very good presentation earlier, so you could watch it again, but I guess I'm just giving you the 4 level of details. I mean 5 in fact if you count 0, and that range from simple original things to blocks to texture roof, more details, interior, and so on. So that is pretty consistent format. I would say that most people are stuck between 1 and 2 kind of things, but that's going to become more and more as vendor like us and other start to adopt that. That's going to bring it to a more mainstream kind of things. So we're going to have a quick demonstration. Actually, my presentation is not going to be that long, but that's all right. So we're going to import building shelf using CTGML. We're going to visualize the building data along with the 3D zoning. So that's going to be an interesting usage. Perform 3D smart editing. That's a tool we built inside BentleyMap. And export the adjusted result back to CityGML for consumption. So here the scenario is a city planner that actually got a building shelf from someone. And he's going to see whether that meets the zoning criteria. Okay? So in many municipalities, they have a limited number of floors they can put in any given zones. That's the case in Toronto, for example. And so, but the contractors always try to push the envelope, so they always try to put more floors so they can make more money, of course. So the city planner's got to deal with that. You could do that in 2D, I'm sure, but it's much nicer to do it in 3D and have a real view of what's going on. And also be able to edit the data, okay? Edit the building exterior to send it back to the contractor and say, here's what you got to respect with that, So don't try to push the envelope too much. So here's again our 3D city model from Quebec. We're going to bring basically we're going to reference a DGN file which contains the zone. Again, it's a DGN with feature coding in it, and that's going to bring us the zoning itself. You could have extruded that, for example, with FME or other things, bring it in, and also I could have imported that from CTGML. We're going to review the attributes of that. That's a type historic, and we don't need to get the number of floors or anything. It's directly 3D, so we can see it. We can also see that buildings actually are bigger than this zone, but it doesn't matter since they have historical right to do that. So we're going now to focus on the study area. That's where we're going to want to put our building there. So first thing we're going to do then is import this building shelf using the CTGML tool to do that. So with the FME tool, excuse me. So that's the dialog I was talking about. Of course, you can browse for all the formats and so on. I'm going to specify my CTGML file. By the way, it could have been a complex BIM model through IFC or anything like that. Doesn't matter to us. We support all of this stuff. It's day-to-day work for the building folks in our context. So we got this building, except that this building is actually a collection of faces. That's important to understand here. So instead of being one solid, so if you want to have attributes on each side and things like that, in this case, it was chosen to model things as a collection of faces. However, when it comes time to edit that, it's pretty tedious, right? You got to move faces around, and nothing is connected. So you want to have real solid to work with. So how do you make the two? So what we decided to do is create the 3D Smart Editing tools, which will allow you to take collection of faces, make solid in memory, okay, to work with, then decompose that stuff back to faces, and then export to CTGML and so on. So even if you don't work with solid, so if, for example, you import a shapefile, which is a multi-patches, for example, not a real solid. So you can actually edit the data, export it back if you need that. So here we can clearly see that our building is too high, and we can also see that it has brought its CTGML attributes in there, no problems. And we can review the attributes just like that, and there's also thematic mapping capabilities and so on, which I'm not showing that here. But then if we want to edit the attributes, we can also do it through the edit dialog over there, and everything is fine. So now what we want to do is push this envelope down a little bit to fit within the zoning. Right? Of course, if we do that through faces, it's going to probably take 20 minutes to actually adjust all the faces so that it comes down to that. So what we're going to do instead is use the 3D Smart Editing toolbar you see at the top right to actually enable and create 3D Solid out of that. And so that's dynamic stuff that happens. So now this 3D Solid, that's a little bug. It shouldn't be black like that, but that's all right. So basically what you can do, and I just want to draw your attention to the number of 3D editing tools there is in MicroStation, is just infinite. You can do everything you want for 3D editing, intersecting solids and name it, they're all there. Surface modeling and so on. So it's pretty complete. But what was the missing link is to say take a GIS data type, which is just a collection of faces, and make it in something that is easy to edit, And that's what we did here. And we're going to preserve the attributes also. So we just select this. We say, okay, now since it's already solid, we can select which face we want to move around. So we decided the top face. So we're good with that. And we're going to simply save our edits and say we're good with this. So now we went back to an actual full features without its attribute preserved from before. Okay, so that's very, very fast in adjusting the data. So then I can just go export to CTGML again if I wanted to. So that was my quick demonstration. But you can imagine the power of this platform to create a lot of data. More than I was seeing another gentleman today building squares and things like that. If you got a tool like BentleyMap, you can create a lot of data very quickly and do pretty good stuff. And then you can export it to CTGML and have other people benefit from it as well. So you can model things as solid if you want, create solids and convert them to faces so that people can work with it, assign attributes and things like that, And so you don't lose the power of the 3D modeling, and at the same time you keep the attributes which you can have for different faces, roof, top, things like that, which will make it very useful for GIS analysis. So CTGML is a complex format. Sorry, Dale, you missed the demo. That's all right. CTGML is a complex format. Bentley and FME helps you to easily import, export CTGML. We didn't want to buy this format. We just thought much better to rely on someone that actually does only that and very nicely. It enables you to leverage as many tools as needed to work with the data in your format of choice. So I think the best tool to do given analysis is what you should use and not try to push the envelope of tools which are not designed to do things like 3D modeling and so on. So it allows you to leverage a true 3D platform to work with the data. And we encourage partners to build application on top of this. There's a slew of applications you can actually build, which are pretty nice. 3D is required for infrastructure work. CTGML is a valid exchange format today, and it's going to pick up in the market more and more. So BentleyMap and FME integration allows users to take full advantage of CTGML and many more other 3D formats as well. So that is my contact information. Any questions on the demonstration?